Okay, welcome back. This is Chapter 9, Section 9.3, where we're going to be talking about the terminology associated with redox processes and reactions. So in a redox reaction, electrons are transferred. One reactant is going to lose one or more electrons, and one reactant is going to gain those electrons that the other reactant lost. So there's always a transfer of electrons in redox reactions. So oxidation is the term we use when a reactant loses one or more electrons. So the reactant that loses the electrons is oxidized, and the process that it undergoes is oxidation. Reduction is when a reactant gains one or more electrons. So there's always this transfer. One reactant is going to lose one or more electrons, and the one that loses the electrons is oxidized or undergoes oxidation. And the reactant that gains those electrons, one or more electrons, is the reactant that's reduced or undergoes reduction. So you can remember this with the saying Leo says Gur. Leo, loss of electrons is oxidation, and Gur, gain of electrons is reduction. So that's how I've remembered it since I took my very first chemistry class. Leo says Gur. I know there's some other acronyms out there like oil rig. You're welcome to use whatever one you want. But I still go back to this even now, teaching chemistry all these years. If I'm forgetting which one is which, Leo says Gur, loss of electrons is oxidation, gain of electrons is reduction, so you never forget. So let's take an example of rust formation. If you've had rusty nails or a wrought iron fence that goes bad, that rusts over time, what's happening is an oxidation process where solid iron is reacting with oxygen from the air to make iron 3 oxide, Fe2O3. So if we assign oxidation numbers in this reaction, iron solid is elemental iron, so it's going to get an oxidation number of 0. Oxygen, O2, is elemental oxygen, so it's going to get an oxidation number of 0. And in our product, the first oxidation rule for oxidation numbers that we come to is the oxygen rule. So oxygen is going to have an oxidation number of -2, which means that iron will end up having an oxidation number of +3, so that they add up to 0 since iron 3 oxide is a neutral compound. So we can verify that this is indeed a redox reaction. Iron went from 0 to +3, and oxygen went from 0 to -2. So there was oxidation and reduction happening in this reaction because the oxidation numbers changed. That's what we talked about in the last lecture. Now we can further define the parts of this reaction using the new terminology that we just learned, identifying what was oxidized and what was reduced. So iron lost 3 electrons. It went from an oxidation number of 0 to +3. Each electron has a charge of -1. So to go from 0 to +3, it lost 3 negative charges. So it lost 3 electrons, and loss of electrons means it was oxidized. That's Leo. Loss of electrons is oxidation. So iron again went from an oxidation number of 0 to an oxidation number of +3. So that means it lost 3 electrons. It lost 3 negative charges. So its charge went up because it was losing negative charge. And so we call that oxidized. If we check out oxygen, oxygen went from an oxidation number of 0 to -2. So this gained 2 electrons. Each electron has a charge of -1. So if you gain 1 electron, if oxygen had gained 1 electron, its oxidation number would be -1. But it gained 2 electrons, so its oxidation number is -2. Label this lost. So going back to Leo says Gur, we identified the loss of electrons, that iron lost electrons. Its oxidation number increased because it was losing negative charge, so it was oxidized, which means that oxygen was reduced because there's always this transfer. So if one reactant is oxidized, the other one is reduced. So oxygen gained electrons, GER, gain of electrons is reduction. So oxygen was reduced. So you should be able to, once you determine the oxidation numbers for every element in a reaction, identify which was oxidized and which was reduced based on if they lost or gained electrons as part of the redox reaction. So kind of to summarize, oxidation is the loss of electrons. So whatever element loses electrons during the redox reaction is oxidized. So the element that undergoes oxidation, we call that oxidized. Oxidized elements are likely to start with a low initial oxidation number, and the oxidation number will go up. It'll become more positive because they're losing negative charge, because they're losing electrons. The reactant that the element is a part of, we call the reducing agent. And I know this gets really confusing because it's the element was oxidized, and then the compound that it's a part of, we call that compound the reducing agent, or sometimes the reductant. It's like, because these always happen in pairs, right? One element is oxidized, one element is reduced, they shuffle electrons around. The agent is like the thing that caused the reduction. So whatever compound contained the element that was oxidized, that compound acted as the reducing agent, like it facilitated the reduction of whatever was reduced. Looking on the other side at reduction, reduction is the gain of electrons. So Leo says GER, the GER part is gain of electrons is reduction. So the element that undergoes reduction, we say that that element was reduced. And reduced elements are likely to start with a high or positive initial oxidation number. And then because they're gaining electrons, they're gaining negative charge. On the product side, their oxidation number is going to go down because they've gained negative charge, they've gained electrons. So the reactant, the compound that the element that was reduced as a part of is called the oxidizing agent, or sometimes the oxidant, because it facilitated the oxidation of whatever other element was oxidized. It kind of helped oxidation happen because it accepted the electrons. And the reducing agent kind of helped reduction happen because it donated electrons, it lost electrons. So the agents are kind of the opposite of what's happening. Whatever is being reduced, whatever element is being reduced, the compound that that element is a part of is the oxidizing agent. And whatever element is being oxidized, the compound that that element is a part of is called the reducing agent. So the reactant that's oxidized is going to tend to start with a low oxidation number that increases because it's going to be losing electrons. So the compound that's oxidized is likely to start with like an oxidation number of, say, -2. And at the end of the reaction, it's gained electrons. So if it gains 4 electrons, it would have an oxidation number at the end of the reaction of +2. Sorry, lost 4 electrons. And for reduction, you're likely to start with an element that has a high oxidation number, and then it's going to be gaining electrons. So its oxidation number is going to go down because it's going to be gaining negative charge. So let's say you start with something with an oxidation number of 3, and it gains 4 electrons. These 4 electrons that were lost are gained by the element that's reduced. So its new oxidation number would be -1. Gained 4 electrons. So when you lose electrons, your oxidation number becomes more positive and goes up. And when you gain electrons, the oxidation number becomes more negative or goes down. And there always has to be that transfer of electrons. So going back to figuring out the agents, we know how to figure out what element is oxidized and what element is reduced by looking at the oxidation numbers. The element that has an oxidation number that increases, that becomes more positive, is oxidized because it's losing electrons. And the element that has an oxidation number that becomes more negative is being reduced, it's gaining electrons. So the compound that those elements are a part of, we call the agents. So iron is the reducing agent because it helped facilitate the reduction of oxygen. Oxygen is actually reduced and iron helped facilitate that reduction, so it's the reducing agent. And then oxygen was reduced, but it helped facilitate the oxidation of iron. Iron was oxidized, so we call oxygen the oxidizing agent. And if these elements were part of a compound, let's say we had like iron nitrate, the whole compound will be called the agent. So it would be iron nitrate is the reducing agent versus just the element iron is the element that was oxidized. So when you're talking about the agents, it's the whole compound that you're talking about as the agent. And when you're talking about just what element was oxidized, it's the individual element. And I know I found this part, I can remember my first chemistry class in college, like this section, I just had a really hard time wrapping my head around, which is why I'm saying it. I feel like I'm saying it 50 times to really, hopefully make it more clear to you than it was to me that elements are what's oxidized or reduced, and compounds that the elements are a part of, those are the agents that help facilitate the oxidation or the reduction. And so again, whatever reactant is reduced is called the oxidizing agent, and whatever reactant is oxidized, contains the element that was oxidized, is called the reducing agent. So let's do some practice. Let's identify if an element is oxidized or reduced, and then let's identify the oxidizing agent and the reducing agent in this reaction. So the first thing we have to do is assign oxidation numbers to every element in the reaction to determine whether or not this is a redox reaction to begin with. You can test yourself too and see if you can identify what type of reaction this is. So we have copper reacting with silver nitrate to make silver and copper nitrate. This is going to end up being, if you want to practice with your reaction types, copper is taking the place of silver. We end up forming copper nitrate at the end, whereas at the beginning we had silver nitrate. So this is a single displacement reaction if you're classifying reaction types. So let's come up with the oxidation numbers for everything in here. Copper, this is elemental solid copper. So it's going to have an oxidation number of 0. It's in its elemental state. Silver is paired with nitrate. So nitrate, I'll show you 2 ways to do this. So nitrate is a polyatomic ion, which means that all of the oxidation numbers inside nitrate are NO3 minus, it's a polyatomic ion. So all of the oxidation numbers from the 3 oxygens plus the nitrogen have to add up to -1. So we know collectively nitrate has an oxidation number altogether of -1, which means that silver must be +1. So that's the fast way to figure out that silver is +1. Collectively, the nitrogen plus the 3 oxygens and nitrate add up to -1 because the charge of that ion is -1. And for polyatomic ions, the charge of the ion is what all the oxidation numbers add up to within the polyatomic ion. The long way to do this, if you wanted to figure out what the nitrogens and the oxygens were individually, is you'd follow the oxidation number rules. And the first rule we get to is that oxygen is -2. And we have 3 of them, which means that whatever nitrogen is has to add up with -6 to equal -1, the charge in this ion. So that means nitrogen must be +5 because 5 plus -6 equals -1. So that's how you'd figure out the oxidation numbers of the nitrogen and the oxygens individually within nitrate, but we collectively know that nitrate overall is going to have an oxidation number of -1 because the charge on the ion is -1. So that's the fast way to figure out that silver must be +1. Okay, so we want to make sure this is a redox reaction. So if we check the product side, we have silver all by itself, elemental silver, so that has an oxidation number of 0. We have copper 2 nitrate. So we know that each nitrate is -1, and we have 2 of them. So collectively, the 2 nitrates have an oxidation number of -2. They add up to -2, which means that copper must be +2 because this is a neutral compound overall. So now we can check. Copper went from 0 to +2. So we know this is a redox reaction because the oxidation numbers changed. Silver went from +1 to 0. Nitrate stayed -1 and -1. So now to figure out what was oxidized and what was reduced, whatever element gained electrons, so it's going to have an oxidation number that becomes more negative because it's gaining negative charge. Gain of electrons is reduction. So silver went from +1 to 0. So silver must have gained 1 electron. It started out with the oxidation number of +1 and it gained 1 electron or 1 negative charge to go to 0. So silver went from +1 to 0. So it gained 1 electron. Gain of electrons is reduction, so that means Ag was reduced. If we check out copper, copper went from 0 to +2. So copper lost 2 electrons. Its oxidation number became more positive, which means it was losing negative charge, so it lost 2 electrons. Because copper lost 2 electrons, loss of electrons is oxidation. So Cu was oxidized. So now we've identified the element that was reduced and the element that was oxidized. Let's now identify the reducing agent and the oxidizing agent. So silver was reduced. It started out as silver 1+ and silver nitrate, and by the end of the reaction, it was elemental silver with an oxidation number of 0. So since silver was reduced, silver nitrate is the oxidizing agent. Let's get rid of some of this extra stuff. So silver nitrate is the oxidizing agent. It facilitated the oxidation of copper. That's what we're saying. So AgNO3 equals the oxidizing agent. It contains the element that was reduced, therefore it facilitated, it was the agent for the oxidation of copper. And now if we look at copper, it's just by itself. If it was part of a compound, it would be the entire compound. But since it's not, we just have copper equals the reducing agent. It contains the element that was oxidized. Therefore, this whole compound facilitated the reduction of silver, so it was the reducing agent. So we have our 4 parts of our answer here. Let me box them up. Silver was reduced. Copper was oxidized. Silver nitrate is the oxidizing agent, and copper is the reducing agent. So once you figure out the element that was reduced, the compound that that element is a part of on the reactant side is the oxidizing agent. And once you figure out the element that was oxidized, the compound that that element is a part of is the reducing agent. Okay, so quick summary of redox reaction terminology. The element that loses electrons is oxidized or undergoes oxidation. That's LEO. Loss of electrons is oxidation. The element that gains electrons is reduced or undergoes the process of reduction. That's the GER part of Leo says GER. Gain of electrons is reduction. The reactant that contains the oxidized element is the reducing agent. We call it the reducing agent because it helped facilitate or reduce the element that was reduced. The reactant that contains the reduced element is called the oxidizing agent, and that's because that reactant helped facilitate the oxidation of the other element. And just note that when we're talking about reducing agent or oxidizing agent, it's the whole reactant compound that's named. And when we're talking about just what was oxidized or what was reduced, it's the individual element. Okay, that's it on oxidation terminology. We're going to talk about collision theory and kind of how chemical reactions happen in the next section in 9.4. Thanks. Bye.